Good morning, ladies and gentlemen. I'm Setia Sari Girsang with the team from North Sumatra Assessment Institute for Agricultural Technology would like to present paper with the title The Effect of the Fertilization and Variety on Maize Productivity in Two Tillage Systems in North Sumatra in the Third International Conference on Food Security and Sustainable Agriculture in the Tropics 2021. Introduction. North Sumatra is the fourth largest maize producer, where Karo district as main contributor that contribute 31.9% in 2019. Even farmers already applied high fertilizer, hybrid maize with high potential, and full cultivated but still low productivity around 7.05 ton per hectare with gap 6 to 7 ton per hectare. To reach the government goal is food self-sufficiency and export. We conducted research with the objectives: the first, to determine the best land management and varieties, and the second is to examine the relationship between soil and maize productivity. Methods: experimental site in maize center in Karo district. The soil type is isohypothermic Andieutheridae suborder. Soil pH slightly acid, high P2O5, low organic matter, and clay loam texture. Research design, randomized complete block design, tillage and fertilization as block, and varieties as a treatment. We have 36 combination treatment with 4 replication, where tillage system is tillage and conventional, fertilization is soil test kit, PUJS, and farmer practice, and 6 varieties are BIMA2, BIMA20, GS27, NASA29, NK22, and P23. Soil analysis using soil test kit, infiltration in the field, while bud density and soil texture in IE-80 North Sumatra laboratory. Observation, plant growth and production. Data analysis using the statistical tool for agricultural research, person correlation coefficient, Bayesian ratio, and climatic data from meteorological, climatological, and geophysical agency. Result and discussion. Table 1 shows the climatic data at each stage has met the growing requirements Wahyunto et al. 2016. Based on daily climatic during the planting season, the plants begins to experience drought at 36 to 53 days after planting. Because of the farmer's habit of full tillage, stubble burning, and no application of organic matter causes of the leaves to roll in this phase. The dominant varieties in all phases in Table 2 are P23 at V6 and maturity in non-tillage, NK22 at V10 in non-tillage, and NASA 29 at maturity in conventional, significantly different from other varieties. At V6 stage, the total dry matter has not shown superior varieties, while at V10s and maturity, the dominant is NASA 29, NK22, and P23 supported by other yield components such as 100 grains, grain yield, harvest index, and harvest index caps. The addition of 2 tons per hectare of organic fertilizer for the treatment, soil test kit, and PUJS has a positive impact starting from phase V10 to maturity. The habit of farmers is additional inorganic fertilizer every year without applying organic fertilizers. Short follow time 1 to 2 weeks to produce a cropping index 2.5 result in decreased soil organic content and maize production. The first non-tillage on dry season with the addition of organic matter was able to increase the mean production by 0.2 ton per hectare with the harvest index and caps harvest index of 0.479 and 0.809 respectively. The combination of organic matter and inorganic fertilizer is very helpful in improving the physical and chemical properties of the soil. The relationship between soil and plant. The negative correlation bulk density to all components is inversely related to infiltration that has a positive correlation to yield component and grain yield. A positive correlation is shown among yield component where grain yield increases with the increasing TDM, harvest index, CAPS harvest index, and 100 grains. Table 6 shows the labor costs are the highest followed by land rent cost. The third highest cost is fertilizer for the farmer's treatment, while the other treatment is seeds followed by loan interest and land tax. Non-tillage costs are lower than tillage because there is a reduction in land cultivation costs, but there are additional pesticide costs. Conclusion: NASA 29 is adaptive and can compensate to P23 and NK22 varieties in terms of growth and production by using PUJS and soil test kit recommendation and non-tillage system. The application of 2 tons per hectare of organic fertilizer with non-tillage system can reduce soil bulk density and is inverse to infiltration and grain yield and yield component. Although the increase in yield with non-tillage using the PUJS recommendation is only 1.1%, it gave farmers a profit of 22.7 million rupiah with a BC ratio of 1.36 due to the efficiency of land processing and fertilization costs compared to the farmer's method. It is necessary to continue this research for several seasons with different rainfall which are associated with a reduction in the production gap and land management. Thanks to the IEAT North Sumatra, especially the late senior scientist Insinyur Akmal MSI for the research facilities provided to the authors.